Good day to you. This is Anagalactic. On a Saturday, the first Saturday in May 2025, we're bringing you the secrets of the universe, and currently we are in a series on the quantum. Now, in this video presentation, I would like to go into a little bit of depth on the current state of theory in cosmic science, as I call it, which has two aspects. It's not precisely cosmological, because that pertains to astronomy alone and is a perfectly reasonable term, as long as one doesn't get too carried away with trying to extrapolate the beginning of the universe. It's far too early in the history of humanity and the history of science to be extrapolating the origin of the universe, although we will address it, because it is a legitimate theory. Any theory which has some basis in experimentation and logic is valid, but it must be considered a theory, a distinction between theory and what would be considered law. We do believe we've found laws of the universe, but from our perspective as finite, very limited creatures on the surface of the earth, we have to be quite cautious in bearing in mind our limitations when extrapolating on extremes, such as the entire universe. I believe it's a reasonable statement to make at the outset that we should be, at the very least, extremely wary of anything said about the universe as a unit, as a whole. And of course, the current reigning model in cosmology is quite extraordinarily extrapolative. We will be going into that to get to the basis of what is currently, and rather ridiculously, called the Big Bang. But we are dealing with the universe now. It is quite a popular model, which is based on a specific theory, which is based on a specific set of observations. So models come from theories, theories come from discoveries, but a theory is something that cannot be rigorously proved. You might ask the question in your mind, as I believe we all must, can the cosmological model be proved? This is a delicate question, the nature of provability. I only mention these things to let you know what we all face, including myself, as we approach this monumentally involving topic. We're all interested in the universe by nature, but the way we're involved in discovering facts, and perhaps even theories about the universe, is involved with a personal equation. Why would you want to know that? I will not be touching on that delicate aspect of the issue in this video presentation. I've made over 950 video presentations in the past 3 years. It's progressive, so I also have to mind my P's and Q's on introducing a topic which may not seem to fit. I'll leave it at that. So now we're going to go into the sequence that I wrote just last night and this morning. All right, this is an expansion of what you just saw, so it's a little easier to read, although I will read this through. And rather than make any more bracketing comments, I believe we're all set to go here, aren't we? Let's begin, and this will become self-explanatory after a certain introductory period. I take a rigorous approach to communicative science, whereby I believe I've felt that I've been forced to adopt certain conventions, which are not conventional conventions. They're my conventions, but they're not meant to be confusing. There's always a trade-off when you attempt your own notation or your own conventionalities. If it's not the norm, it does require a little, you've got to adjust to that man's penchant. So it has to be justifiable. I believe everything here will be justifiable. Let's go. I entitled this Euclidean null theory. That will become clear why I named it that in a moment. This is an inductive sequence, which, in my view, is invert from a deductive approach, which is, I believe, how we ordinarily think, rather like Sherlock Holmes in the sense of science. But induction is synthesis. It's putting things together. You get a bunch of facts, but it's not knowledge unless you can organize it. And why do that? So you can gain understanding. How do you gain understanding? Synthesis. All right, that's a lot of information encapsulated into a quick rubric. Euclidean null theory. What is the Big Bang theory? What is the supermassive black hole theory? What do these theories have in common? The answer to the last question is known. Before commencing, we require a short glossary. Anagalactic selectively uses, in place of a period, a bullet. Sometimes at the end of a sentence, particularly with mathematics in it, particularly with an equation at the end of the sentence, a period may be ambiguous what it means in scansion, whereas a bullet is a full stop. So that's my little convention. I hope that's congenial to you. It certainly is to me. So to go on, AE, which is a Latin ligature, a single glyph, which is a combination of two English letters, I use as a pronoun now in writing. That is, you should pronounce it I, as in, well, just I. So AE, the ligature, is a pronoun used for myself, representing my station anagalactic, which is non-ambiguous because I'm the only person in this institution. All right, the BH, or just BH. This is the first of my questionable conventions, but I hope you adapt to it quickly because it's going to save a lot of space. And once you get used to it, which I think will be very quickly, BH is simply an abbreviation for supermassive black hole. Now, I do need to make a quick interjecting comment here. There is such a thing as a black hole without the prefix supermassive. And in fact, the way the black hole phenomenon was discovered was a stellar phenomenon in a binary star system. We'll be getting to that, so I hope that doesn't throw you off. But BH could be considered an abbreviation for black hole, which is distinct from supermassive black hole. But we won't be talking about the black hole stellar phenomenon, but rather the supermassive black hole, because it's a galactic scale phenomenon rather than a stellar scale phenomenon. So BH stands for supermassive black hole. BB stands for the Big Bang. I believe that'll be congenial to anybody, because I don't see how a real scientist could not get sick of hearing that goddamn term. A very childish and anti-scientific term. It's misleading for one thing, but the list of objections to that term are, it's a long list. The Big Bang is a ridiculous term, so I'm just going to abbreviate it BB. Now, the next three bulleted items here, I'll just highlight this. I use QM for quantum mechanics, and then the last two are the result of my own research and, I claim, discovery. Or discoveries, more than one discovery now. That symbol that you see here, a circle with a cross through it, stands for the circumference of a circle. And this next symbol, a circle with a X through it, stands for the sphere. All right, we're going to go on to the next page here. Good day, this is Anagalactic, AE. When it's not used as a pronoun, it's pronounced AE. but when I use it as a pronoun, as you'll see me do sometimes, just pronounce it I. I don't like to use the pronoun I now that I have a choice. You may find this interesting in your own life, but it's really just my little conventional system, which I would say for an ordinary scientific mind is not a challenge to get used to. As long as it's not involved or convolute or just is jarring in some way, these are just ordinary standard notational conventions that I'm adapting to my own use. All right, when referring to BB or BH, the article the is dropped. You shouldn't say the supermassive black hole as if you knew what it was. There are many of them. Now, the Big Bang is a little different, and there you might, I believe it's unavoidable to use the article. I simply won't, because it's a theory. It's not really substantial in that aspect. It's not as substantial as a law. So in referring to BB or BH, the article is dropped. BB is a singularity. That is the gist of what came to me last night and got me out of bed to write for an extra hour or so. BB is a singularity. Just to translate that back to the common jargon, the Big Bang is a singularity. The question is, what is a singularity? That's what I'll be answering for us today. BH is a singularity also, so that's what they have in common. They're both singularities. Now, another convention, this is simply for writing, but I'll read it to you since it's here. Endnote references will be indicated in line with brackets, and you'll see the notational system that I've adopted. This right here, highlighted, refers to an endnote. Instead of Milky Way, I shall prefer the Latin Via Lactea. That's a little arbitrary, but I hope you adapt quickly because I just don't like Milky Way. It just sounds superstitious. Now, what does Via Lactea mean? Milky Way. Okay, instead of Virgo cluster, which is the cluster of galaxies in which we reside, essentially. I like that term, Virgo cluster, but it has the word cluster in it. And I've renamed the cluster to something much more scientific. Cluster just means a clump. But a cumula is a meteorological term referring to a cloud. Now, Edwin Powell Hubble, whom we're coming to very quickly here, never referred to a galaxy. I don't know if you're aware of that. I actually did some research to see if toward the end of his life, Powell ever used the word galaxy. He was from a generation that goes back into the 19th century, of course, because his discovery was made in 1926. And he preferred the word nebula for galaxy. Now, I capitalized on that, and he also wrote a book called The Realm of the Nebulae. Now, the AE, of course, is Latin plural. I don't see anything wrong with that, except historically, nebulae, the word nebulae is a class word, referred to anything in the sky that was fuzzy, and only one of those types of objects turned out to be a galaxy. Andromeda, for instance, was called a nebula, and Powell never dropped that word. He never used the word galaxy. Now, if you know differently, I would reward you in some way if you could give me a reference to Hubble ever having referred to a galaxy. But they are synonymous when you narrow down nebula, and that's why it's preferable to have another word. So I invented the word cumula, which would be cumuli in the plural. So instead of Virgo cluster, AE prefers Virga cumula, making both, I believe that's feminine ending. Cosmic distances beyond the Virga cumula are extracumular. Now, extragalactic is very similar. It just means outside. But if you're outside our galaxy, the first cosmic unit up as you're going out from our galaxy, is our local group of 3 spiral galaxies, plus a plethora of dwarf galaxies and satellitic galaxies. All right, I hope I have more here. Okay, I don't. Now, I'm going to switch back here. All right, so here is our beginning of our definition of singularity, which I claim is the common feature between BB and BH, between the Big Bang and the supermassive black hole. Each of them defines a singularity. In both cases, BB and BH, their theoretic basis is singularity, which is the geometric definition of Euclidean null. Now, I've covered this so many times, I don't wish to repeat myself, but I also don't like to send my listeners back to do homework, although I do recommend it if you have time and inclination. But it is the duty of an expositor, a presenter, to be self-contained. I believe that that is the right way to approach things. So I will just mention what is meant by Euclidean null. It's so simple that it's easily overlooked. It is the very first sentence in Euclid's Elements, the most popular book ever written, matched only by the Bible, and it's a matter of debate which one has more additions, however you define additions. But Euclid's Elements is the scientific equivalent of the Holy Scripture because of the first 2 sentences. Although people have various opinions on the value of the entire work of Euclid, I certainly believe that that entire book, which is quite long actually, Euclid's Elements, has a lot of very interesting geometry in it, which has fascinated the minds of men for 2,500 years. But the first 2 sentences are the axiomatic basis of science itself, which I claim to have gained an insight into. So this is to lead up to my proposed discovery. I have made a discovery that means something to me, but in science, you have to communicate it. That's what science is. If you hold it in and just say, oh my God, I know everything about this, that, or the universe, everything, and you don't share it, it's not science. You may say in your own mind that it's science and you got it and everyone else, can't catch up. It's meaningless in terms of science, so it's not science. Only when it's shared, and then there's more to it, because of course other men have to be able to see what you see. The basis for establishing your trust in another man's insight is not the man, it's the proof. Okay, that's the basis of science. So Euclidean null is the point. And if we could translate Euclid into modern language, I don't think any physicist or mathematician would disagree with my equivalency or summarization of what Euclid said. He said that it was an object that has no length, breadth, height, or width. Really, he's talking about the 3 linear dimensions, but it has none of them, which is a most provocative thing to say. And the reason that he began with that sentence rather than with an axiomatization of the line, which is what he wanted, he had to, and this is Euclid's amazing insight, which I still consider, I believe with all scientists, to be one of the most profound inductive insights ever achieved by the mind of man. This was 2,500 years ago, so of course it's at a very relatively primitive level, but it stood the test of time, and you've got to say something about that. It's amazing. And I was able to discover, along with some help from John Horton Conway, why Euclidean null is such an amazing insight. It carries a certain price tag, which we'll get into, but essentially without Euclidean null, you can't develop a number system. And the line, this is an ordinary straight line, is the number system. All the number systems in that Venn diagram, which I've shown, you can look that up in Wikipedia. What is a number system? Well, there are several. About 6 or 7, you could say. And one of them is different from all the others, the complex number system, because it has a two-componency. Linear numbers are one-componency numbers. Obviously, 1, 2, 3, 4, they don't go together. If you want to put them together, you use an operator. Complex numbers are a number, that is, but if you look at the number, it's two numbers. And we won't go into that, although I've given several video presentations on the complex number system. It's really an amazing system, but also carries a price tag. All right, we're getting there, but I don't want to go off on tangents. But remember, we're addressing cutting-edge science now, so there has to be some balance between, why this is important, and that it's a real art to present science at this level. And I've been practicing for 3 years. I hope I'm getting better. By the way, I just got a wonderful comment between the time that I composed this document last night and this morning. Someone left a comment which made the hair on my arm stand up. Now that could be bad if you get, I was called an asshole last week, and I know why. I knew I was going to step on someone's toes when I talked about Eric Weinstein. But you can be called an asshole. You just got to let that roll off your back. I gave him a very polite and friendly and encouraging answer. I wanted him to explain himself so I could correct myself, so he wouldn't think that I was an asshole. I don't want to be thought of as an asshole, although I might be. Maybe it's unavoidable. But the comment I got was that basically said, I'm damned angry that you're not more famous because your presentations are excellent. And I was like, a guy in my position really enjoys hearing that. So I'm feeling pretty good for that reason, among others. So let's go on. Our introductory purpose is to define this term singularity. Now what I'm going to attempt to show to you is a singularity which is at the center of BH and at the BB. Both of those are considered to be a singularity. Well, what is it? I will tell you. It's Euclidean null. Now I have to prove that. We shall now want to explain how these theories developed. We're not so much interested in Euclidean null or singularity, except to get at these two theories. How did they arise? Are they valid? And if so, how far are they valid? Because we are talking about things we can't take into a laboratory. So to explain these theories in an understandable way, this is synthetic, we want to employ the strategy of David Bohm, one of my heroes. When Bohm attempted to explain quantum mechanics, he promised in his preface to explain it in 3 ways: experimentally, mathematically, and physically. I've given several presentations over the past 2 years on David Bohm's approach to quantum mechanics, which is somewhat unique. But in his 1952 book, which Albert Einstein acclaimed, that's saying something. It was called Quantum Theory, a rather long book, about 620 pages long. I own a copy, and I attempted to penetrate it as much as I could. But it turns out the most significant part that I was able to glean from David's classic book, it's considered to be a classic, is that he was trying to explain quantum mechanics physically. And I believe he did as well as anybody could, but it's not possible to do that fully. That's why there's a quantum paradox. So he was attempting to give a physical explanation of quantum mechanics. as it existed about 75 years ago. And to do so, he pointed out very carefully, and in fact repeatedly, he said that it's pure mathematics. It's not physical. So it's quite difficult to translate between mathematics of quantum mechanics and what it refers to. Because the paradox is nobody's sure what they're even looking at or talking about. It's a weird, weird situation. But one of the most significant aspects of his approach is that he begins by recounting the experiments, how these things were encountered, how the quantum phenomena were encountered in experiments, or to get measurements, of course. So we follow David in first tracing the experimental trail. Now I'm going to do that both for BB and BH, but we're after BB. We want to know where that theory came from. It's considered by many to be law, but when pressed, most of these top-notch physicists will back down a little and admit, oh, it's just a theory. And as soon as they're done saying that, they go right back to treating it as if it were a proven law. That's a hazardous thing to do, but it's universal now with a certain class of scientists. They're well-paid, well-heeled scientists, exclusively. Well, there's an overlap. We are scientists, but we're not necessarily PhDs, teachers, professors, writers of books, presenters on YouTube. I'm a presenter on YouTube, but that's because I'm trying to raise my game, because I'm trying to communicate. All right, so let's start. The experimental sources of BB. BB evidence first appeared in the discovery of nebulae. I introduced that Hubble always called galaxies nebulae. And nebulae was the discoverer's name for galaxies. Now, we'll then turn to experimental sources of BH. And BH evidence first appeared in the discovery of Cygnus X, which was about 1960, which is going back about 80 years, I believe. So the Big Bang was discovered around 1930, but the black hole was discovered around 1960, about 30 years later. So the Big Bang came first. Now, BH was first discovered in a star system, so it's not a supermassive black hole. Cygnus X, as it was called at the time, was a binary star system with an invisible companion. All right. Thus far, we have only sketched the original discovery in each case, which began the process of theorization. To complete each discovery sequence, that is of BH and BB, we first select the first discovered theory, which is BB. Now on this bulleted item, we're just going to add a little bit of information to Bohm's preferred sequence of experiments. Following the discovery of galaxies, made by Edwin Powell Hubble, dated usually to 1926, when he discovered that Andromeda and a few other nebulae were actually outside of our own star system, now called the Via Lactea or Milky Way galaxy. That was not known for certain before 1926, although for approximately 50 years before Hubble, there were a lot of astronomers who knew that those were island universes, as Kant called them. Following the discovery of galaxies, a linear relation was discovered to exist between two measurable quantities in galactic light. The relation was found not to exist consistently in the intergalactic space closest to Via Láctea. However, beyond the range of the Virga cumula, the linear relation becomes definable. All right. I'm going to go on here. The two related quantities are distance and redshift. What is meant by redshift is a definite measurable change in the light profile of the galaxy being observed outside our own galaxy, using the sun's light profile as a baseline. The reason for the term shift is a measurable shift in the spectrogram, which is a superposition of two different aspects in the light profile. The spectrogram itself, either of the sun's light or of the distant galaxy's light, is composed of a continuous band of frequencies interspersed with certain lines, which represent a phenomenon affecting the spectral band. You know of these as absorption lines, and there are actually two types of line superposed on the continuous spectrum, as it's called. Absorption lines are the ones that we're talking about, but there are also emission lines, which are basically the ghost of the absorption line. Be that as it may, though there are lines in the spectrum that are somewhat independent of the spectrum itself, as was discovered. These lines represent a phenomenon affecting the spectral band, as I just described. In effect, the lines are fixed to the band for sunlight. So that's our baseline, where these lines occur. They're quite specific. In effect, the lines are fixed to the band for sunlight, but are not fixed in extracumular space. Now, you've heard the term extragalactic. That would essentially refer to just outside our galaxy. But extracumular is it's a significantly larger part of space. So it's much further out. How much further? We'll get into that. The lines remain fixed in the solar spectrogram. That is, it never changes. This is not a variable phenomenon for the sunlight, for the sun's light. The lines remain fixed in the solar spectrogram, but in extracumular spectrograms are consistently shifted toward the low-frequency end of the band. The current Wikipedia article on redshift, as of May 2025, gives a virtually monumental recount of how the concept of redshift was theoretically delineated or extrapolated. And that ends our presentation for today. But you can see this is the beginning of a series. I just want to give you a little summarization of why I believe this is so important, so that you'll know the thought processes going into what is coming next, so you might want to stay tuned. I certainly hope you do. That's why I make these presentations, is to give you valuable information. This is not meant to be primarily entertainment. Although I like being an entertainer, I'm quite a cut-up when I want to be, especially in the days when I drank beer, which have been over for quite a while now, because I can't afford to be intoxicated when I give these presentations, but man, did I have fun in the first 2 years. I wasn't soused every time, but I would drink on the order of a 6-pack of beer every night. Well, at my age, you really need to cut that back. That's for youth if you feel indulgent that way toward alcohol. Beer is a mild form of alcohol because it's much more water than alcohol. But I've had a whale of a good time on beer, but I'm going to have a whale of a good time without beer now. All of which is to say, I've come a long way in 3 years, and I'm about to go live stream. Well, a lot of my viewers are highly expectant of that. I know that now. and I've had to delay because of some amazingly synchronistic, just huge fiscal problems. It just, as soon as I said ready to go live stream, I had a broadband connection at the time, I was hit with a series of financial setbacks, which I just simply don't want to burden you with, except to explain that as soon as I said we're going live, everyone was excited, and then I couldn't because I had to downgrade to a Wi-Fi. You can't do live streaming with a Wi-Fi connection, although it has been done. I could not make it work very well. But now I have a broadband connection again, which is another story of synchronicity, this time good. But what we're heading toward now is live streaming, because this has to be interactive. The name of my site, fully, Anagalactic, is just short, and AE is just an abbreviation for Anagalactic. But the official name of my site is AEIOU, which I think is rather clever, considering it stands for Anagalactic and Extragalactic Interactive Online University. Interactive is critical for scientific communication because you have to ask questions. If it's a discovery, as I claim this is, actually now it's a whole list of discoveries. I know this sounds grandiose, preposterous, precocious, pretentious, and pompous. So was Einstein, okay? Which already, okay. So we're gonna stop here. Thank you so much for tuning in. And the gentleman who left a comment on my video, the collapse of the wave solution, basically the extended edition, I believe I called it. Thank you so much. I clicked on your link, and I see you like music. I just wanted to listen to some of the music that you like. I want to tell you, sight unseen, I like you. I have every reason to like you, so, but looking a little closer into what you like, I really enjoyed your selection of music. And thank you so much for your comment. All right, I don't want to get too emotional here, but one last comment. My paper, which I have to produce this, but I've been forced to delay for, not forced. I am producing the paper, and it's coming along well, but this has to be done exactly right. It's going to come out in LaTeX form, so you can get it as a modified scientific paper, such as you'd find in a journal. But and that will be at the GitHub IO site that I own. It's free at GitHub. You can actually have your own website. There's no bells and whistles, but there's also no overhead. They don't charge anything, so it's a free outreach, and it is HTTPS. Some people are a little paranoid of the internet. I won't make any comment there. I am not as paranoid as some people are. But so you don't want to just jump into someone's site, because there are quite a few landmines out on the internet, and you should have at least some form of protection on the internet so that you don't get sucked into something that's going to maybe compromise you in some way. I personally don't see how that could happen at the GitHub site. But there's a less secure site called Google Docs. I don't see that Google Docs has been used very much. It's not very famous, but it's been around a long time. And it is a place where you can have a website where you produce documents. And they are documents, so it's not really a website. At GitHub IO, it is a website. You have full control over the HTML, CSS, and also JavaScript, so the full boat. But at Google Docs, it's documents that you upload, and you format them with a word processor. There are various formats that are supported. So my document, officially called a paper, will be there as well in text format. But one of the advantages of Google Docs is that you can collaborate. That when someone sees your document, they link to it, you can actually make comments if the producer allows it, which I will. And then I'll be able to see your comments. And these are in sequence. That is, I believe it's called inline or in situ, where it's not just a general comment and you have to refer to where in the paper you're referring. You can put it right alongside the paper where it linked to what it is you're referring to, where you want to make your comment. And then I can see your comment and respond. Now in live stream, there will be a chat box. It's off to this side for me, but I'm not sure how it's presented. Well, I have used live streaming as a viewer, so I've seen it. It has a running sequence where people can type in. It's kind of mixed, so you do have to understand your audience. Needs to be civilized, because you can make any comments you want. Well, I want that, and I don't shy away from negative comments. There should be some negative comments, because this is somewhat challenging, I would have to say. I am attempting to reapproach certain models. In fact, virtually all the models in science are affected by my discovery in geometry and our number system. So this is Anagalactic, bringing you a somewhat extended. I like to keep these videos to 30 minutes because I think that's a good chunk, but I never, very rarely achieve that. I usually go about 40 minutes. So there's that overlap. Thank you for tuning in. Keep looking up. It is a waning new moon. Haven't reached the first quarter yet. Beautiful skies here. I am in a city and I am at the bottom of a valley. Not the best place for astronomy. You can always look at the moon. I've given several presentations on the moon, which I call lunar geometry, because that's how all children, every child, learns geometry originally directly from the universe, from the moon. All right, keep looking up. We'll be right back with BB and BH and Singularity and Euclidean null and a full explanation that I know you're going to like.